Okay, what are we going to do? Can I have attention, please?
Okay, before we start the lecture, I'm sure like also that's all about essentially what do we want? We want to learn how to translate graphs. Let's say you are given
y equals fx. Do we know how to sketch y plus b equals fx? Let's say y plus 2 equals fx. Do we know? That's not what we want. Do we know how to sketch y equals x plus b? Okay, maybe you don't know what I'm talking about now. Let's use a very simple example. Let's suppose we have a graph y equals x plus 2. Okay, no problem. If I say replace, do we know how to sketch y plus 3 equals to x plus 2? Yes, of course you say yes, because you minus 3 on both sides, you'll get y equals x minus 1. So we will get something like that. This is one of the things we're going to learn, okay? Okay, you replace y with y plus 3, we know how to sketch. Can you have attention, please? I hear a lot of whispering. That's one type. The second type we're going to learn is what if I say I replace x with something. So I say, let's say y equals to x plus 3 plus 2. What is it? That means I replace x with x plus 3. What is it? Of course, you all know that y equals x plus 5. Alright, y equals x plus 5. X plus 5 is something like that, of course. So that's the second thing we're going to learn. Can? Okay, so far like that first. Okay, let's deal with these two types first. So what we're going to talk about is the first two. Can? And then subsequently we're going to talk about scaling. That means replace y with 2y, replace x with 2x, sorry. Okay? Then later on we'll learn about reflection and all. And then we'll learn combination. So essentially we want to know Okay, essentially we want to know if we know y equals fx, how do we transform to other graphs. Okay, let's start. Let's take a simple graph, y equals x cubed. Of course, we all know how it looks like. When x is 3, y is 27, x is 0, y is 0. And x is negative 3 here, you get negative 27. Now the question to ask ourselves is this. What if I change y to y plus 5? That means replace y with y plus 5. What do we get? Now, of course, all of us can do the calculation, but let's go through the thought process here. In order to get 3 here, what should be my y? Look, I get 3 here, I get 27. Alright? How do I get 27 on the right hand side? I must take 27 minus 5. Y must be 22. Not plus 5. In order to get the right hand side equals to 27, my y here must be 22. So, here we have, it must be there. Of course, let's not focus on arithmetic. Arithmetic everybody knows, but think about it. In order to get this point, let's see this point here. X is 3. X is 3. In order to get 3, I must take 27 minus 5. Because x cubed is 27, I must take 22 plus 5. 27 minus 5. You follow what I'm saying? So in the same way, Of course, I'm not going to repeat. In the same way, to get x close to 0, alright, I must take this value minus 5. This value minus 5. Do you follow? So which means for every single point here, in order to transform here to here, I will take all the y values minus 5. Okay now? Are you okay? Okay. So, how do we describe this transformation? Down, very good. Very layman language. Excellent. Down. Move. Shift. Come on, drop. Okay, good. Come on. Plunge. The points coming in. Okay, in mathematics, we don't use all these terms. Transform. Transform is generally speaking. Any more? Translate. Excellent. Very good. You want to be a math teacher next? Where? Very good, Tristan. What's your friend's name? J. A translation. You want to be captured on the recording, right? Okay, very good. Which means all the points here, alright, all the points here will have their y coordinates. Okay, y coordinates will be subtracted by 5. So therefore, it's the whole graph, okay, translated 5 units to the negative y direction. Can we all take a look? You see, it was y here, it is y plus 5 here. But instead, you actually translate in the negative y direction. So it's a bit counterintuitive. You know what I'm saying? It may seem like you take y plus 5, you translate upwards, but it's not. Okay? But if you follow this argument, you know that it should be what? Translated by units in negative direction. Okay, actually this is repeating. Okay? You can read. Let's take a look. Are you okay? Yeah, good. Okay. Actually, you can copy, but I've said what I wanted to say. This point is now mapped onto this point on here. Because to have the same x coordinate, which is 3, alright, your y coordinate is to be subtracted by 5. That's all. I said it just now. So, if I have a coordinate hk on the original graph, then the transform graph should have hk minus 5. Am I right? Because all your y coordinates are now subtracted by 5. Okay. Now we talk about B positive. Can you take a look? Assume B is positive. What happens? This group okay now? Why so excited? What is this transformation? I just said. Correct. It is the graph of y equals to fx is translated how many units? Negative b units, or you can say translated b units in the negative y direction. Excellent. Okay, I repeat one more time. It seems counterintuitive because you change this y to y plus b. It is a translation, yes, in the y direction, but it's actually in the negative y direction. What if it's y minus b? Yeah, okay lah, done. Okay, Okay, good. Just change the negative to positive, done. Just a quick summary. This table is not meant for you to memorize, okay? Really, it's not meant to. If you understand the principle of it, there's no need to memorize. No need to memorize. Okay? Look, if you replace y with y minus b, okay? Y is replaced by. Are you okay? Can? Too easy, right? Way too easy, okay. Somebody asked me whether this one hard or not. Solve, right? So, no, it's quite solved. Same quality, about the same throughout all the chapter. Okay. It's translated in the positive y direction. This one, if it's y, we place y minus b, positive y direction. It may seem trivial, don't let me catch you doing silly mistakes, okay? So HK, you keep the x coordinate, all your y coordinate will be k plus b. Okay? And then this one is the same, Okay? Let me see whether we have time for one example. 1 minute. No, I'm not asking a question. If I ask a question, you all will all say no. I'm just asking myself. Okay, no time. Declare, no time. Okay, I'll see you next week.